Today we're going to learn about writing polynomials given the zeros or given the answers. Prior to now, we've been solving for the missing answers, so this time we're working backwards to find that original polynomial. It says, how can you derive a polynomial equation that has imaginary solutions? We're also going to talk about radicals or just whole numbers too as well. I've kind of combined them into one. So example 1. Write a polynomial function of f of least degree, so the smallest power possible, that has rational coefficients, so no imaginary coefficients, a leading coefficient of 1. All of these will have a leading coefficient of 1. And given the zeros of -2, 0, 1, and 7. So those are your x values. So first thing we have to do is imagine what they would look like in parentheses in factored form before you solved it. So we know that -2 or -2 would be x plus 2. We know that x minus 1 would be 1. And we know that x minus 7 would be 7. Now for 0, all you have to do, if you remember, that's when the leading coefficient or the leading term is just an x. So we have x, x plus 2, x minus 1, and x minus 7. And these can be in any order. They are commutative. I always list the x first. Now, whenever you encounter 4 different things to multiply, it helps to kind of break them up into groups. If it's 3, I just pick any 2 and multiply them, and then multiply by the third. But when there's 4, I kind of group them. So if you notice, I kind of color-coded it. I'm going to multiply the first 2 together and the second 2 together, and then I will combine them. So if I take x times x, I get x squared. X times 2, I get 2x. That is my first set of parentheses. Now the second 2 I'm going to have to FOIL, so x times x is x squared. Outsides we get -7x, insides we get -1x, and -1 times -7 is +7. So to make my life a little bit easier, combining my like terms, -7 and -1 make -8. And now I have a binomial times a trinomial. Now some of you will make a 2x3 box at this point. Some of you might line things up vertically, but I'm just going to multiply this out all horizontally to save some space. So x squared times x squared is x to the 4th. X squared times -8x is -8x cubed. X squared times 7 is 7x squared. Now I repeat the process with a 2x. 2x times x squared is 2x cubed. 2x times -8x is -16x squared. And 2x times 7 is 14x. Okay, my leading coefficient, if you look, is still 1. No different here. So now all I have to do is combine like terms. So I have x to the 4th. I have -8x cubed plus 2x cubed, which is -6x cubed. I have 7x squared and -16x squared, which is -9x squared. And then I have 14x at the end. Now, if it said it wanted a leading coefficient of 2, then all I would do is take this answer and multiply by 2. It would still give me the same exact zeros, but all the ones we're going to do are going to have a leading coefficient of 1. Let's try another one. Now, this one, we're going to throw in some square roots. The irrational conjugate theorem states that let f be a polynomial function with rational coefficients. Let a and b be rational numbers such that the square root of b is irrational. If you have a plus the square root of b as an answer, basically, you have to have a minus the square root of b as an answer as well. So the first one I'm going to do in this case, this is example 2, if you notice, the same instructions. I'm going to have a 0 at -4, and then if you notice, I have a negative square root of 5. Well, that rule says that if you have to have a negative square root of 5, you must also have a positive square root of 5. So then I write my polynomials. So I say -4 would be x plus 4. Okay, I have to have a negative square root of 5 and a positive square root of 5. So I have a negative square root of 5 and a positive square root of 5. Now, when you encounter this type of problem, you always want to make sure to multiply your square roots first. Otherwise, you're going to end up with a whole lot of mess. It's easier to do this part first and then condense it to a nice, pretty polynomial that's easy to FOIL. So that's what I did. X times x is x squared. X times square root of 5, since x is not inside the radical, will go in front of it. Negative square root of 5 times x is negative x square roots of 5. And then a negative times a positive is a negative square root of 5 times 5, which is 25. Now, x square roots of 5 and minus x square roots of 5 zero each other out, so those go away. Square root of 25 is 5, so it's x squared minus 5. That is why we have to multiply by the conjugate. We want those middle terms to follow out. We won't want any square roots left. Now I have a 2 by 2. I can either make a box and FOIL it, or I can just turn around and FOIL it out, which is what I did. So x times x squared is x cubed. X times negative 5 is negative 5x. 4 times x squared is 4x squared. And 4 times negative 5 is negative 20. And there's my answer. Now let's try one with a complex value. So then this one, excuse me, this one I'm going to do zeros at 2 and at 3 plus the square root of 7. Okay, so if you notice here, I have 2 is minus 2. Okay, so I do x minus 3, because this is a positive 3, minus 3 plus the square root of 7. But remember the rule you must have, it's conjugate as well. So we do x minus 3 minus the square root of 7. Since this is a positive 3, these will both remain a negative, just like with whole numbers. Just like before, I'm going to repeat the process with my trinomials at the end, and I'm going to FOIL. Now, this gets kind of messy, so if you want to line things up or make a 3 by 3 box, I understand. I'm going to kind of walk you through it. So, x times x is x squared. X times negative 3 is negative 3x. X times negative square root of 7 is negative x square root of 7. Notice my x just goes in front as a coefficient. Now I'm going to repeat the process with my negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 3 is 9. And negative 3 times negative square root of 7 is the positive 3 square roots of 7. Now I have square root of 7. Square root of 7 times x is x square roots of 7. Square root of 7 times negative 3 is negative 3 square roots of 7. And square root of 7 times negative square root of 7 is negative 49. Now, at this point, there are a lot of things that will cancel out. So I'm going to grab something and start canceling some stuff out. Well, I see these two inverses, so those go away. I see these two inverses, so that goes away. I know the square root of 49 is plain old 7. So now what do I got to work with? So I have x squared, negative 3x and negative 3x make negative 6x. And then I have 9 minus 7, which is 2. Okay, I have a binomial times a trinomial. So I'm going to either make a 2 by 3 box, or I'm going to just distribute and distribute and distribute. X squared times x squared is x to the 4th. X squared times negative 6 is negative 6x cubed. X squared times 2 is 2x squared. Now we repeat the process with my 2x. 2x times x squared is 2x cubed. 2x times negative 6x is negative 12x squared. And 2x times 2 is 4x. I combine my like terms. I have x to the 4th. Negative 6x cubed plus 2x cubed is negative 4x cubed. 2x squared minus 12x squared is negative 10x squared. And then I have a 4x at the end. So that is example 3. Now the thing we haven't done is imaginaries yet. So the last couple are going to throw in some imaginaries. Now first, the complex conjugate theorem basically states the same thing. If I have a plus bi, I have to have a minus bi. We have to always have the conjugates. So here's my problem. Write a polynomial function f of least degree that has rational coefficients, a leading coefficient 1 and zeros at 2 and 3 plus I. So 2 would be x minus 2. 3 would be a negative 3, so it's x minus 3 plus I and x minus 3 minus I. Because remember, we have to have both of them. So then I FOIL or distribute my two trinomials. X squared minus 3x minus xi. Minus 3x plus 9 plus 3i. Xi, negative 3i, and I squared is negative. Okay, I'm going to cancel out or reduce anything I can reduce, making my life a little easier. These are inverses, so they cancel each other out. These are inverses, so they cancel each other out. Okay, I squared is negative 1, but there's a negative in front, so that becomes a positive 1. So then I have x squared minus 6x, and then 9 plus 1, which is, oop, I did that wrong, 10. There should be a 10 here. Double checking my work. I had 9. Yep, should be 10. Okay, so then I'm going to FOIL. Now, some of these terms I'm going to have to change as we go along. So x squared times x squared is x to the 4th. X squared times negative 6 is negative 6x cubed. X squared times 10 is 10x squared. 2x times x squared is 2x cubed. 2x times negative 6x is negative 12x squared. And 2x times 10 is 20x. From there, I combine my like terms. I have x to the 4th. I have negative 6x cubed plus 2x cubed, which is negative 4x cubed. I have 10x squared plus or minus 12x squared, so that becomes a negative 2x squared. And then I look at my constant, and now this becomes a 20x. So we have to be careful with those guys. We always have to be careful. Whoa, nobody caught my error? That should have been x minus 2. I knew I did something wrong. This should have been an x minus 2. Why didn't somebody say something about, oh yeah, you can't answer my questions? What greatness. It wouldn't be a Theorem video without an error. This would become x cubed. X times negative 6x would be negative x squared. Thought something was wrong. And x times 10 is 10x. Then I repeat the process. Negative 2 times x squared is negative 2x squared. Negative 2 times 6 is negative 12x. This problem has all sorts of problems. And negative 2 times 10 is negative 20. Now, I would re-record this, but unfortunately, with the snow day, I'm just going to have to post it. And those of you who are absent will just have to make do with this. So then I combine my like terms. X cubed. Negative 6 minus 2 is negative 8. 10x. Now you might be asking yourself, Mrs. Doran, why did you get to the end of the problem and realize you had an error? Well, remember we talked about, it's called the fundamental theorem of algebra. Basically what it says is your degree should never exceed the number of solutions you have. Well, if you remember, we had 1x here, 1x there, and 1x here, which is x to the 3rd. Originally, when I did this problem, I got an answer of x to the 4th, which is not right because I should only have an x to the 3rd. So that was an easy way of me checking it. Let's try one which I hope has no errors. So example 5. Write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1, and zeros at 3, and negative 1 plus I square root of 5. Okay, so 3 would be x minus 3. Negative 1 would be plus 1, but since it's attached, I have to put plus I square root of 5 and minus I square root of 5. Notice this is a whole term. That's why I don't just have negative 1 and then a separate problem. So negative 1 would be positive 1 plus I squared of 5, negative 1 minus I squared of 5. So then I FOIL. X times x is x squared. X times 1 is 1x. X times negative I squared of 5 is negative xi squared root of 5. Now we do 1. 1 times x is 1x. 1 times 1 is 1. And 1 times negative I squared of 5 is negative I squared of 5. Now repeat the process again. I squared of 5 times x is xi squared root of 5. Notice I'm listing the x first just because that is a real number. We just don't know what it is, whereas I is imaginary, and remember it always comes second. Then I do I squared of 5 times 1, which is 1 I squared of 5. And then I times negative I is negative I squared. Square root of 5 times the square root of 5 is square root of 25. Okay. Now I got to combine all this stuff. And it should end up being this nice, pretty little thing down here. So negative xi squared root of 5 should cancel with positive xi squared root of 5. Negative I squared root of 5 should cancel with positive I squared root of 5. Well, let's see. 25 is 5. So this is negative times a negative 1. So positive 1 times 5 is positive 5. So this is plus 5. Hey, I didn't make a mistake this time. Rock on. So I get x squared, 1x, and 1x make 2x, and 1 plus 5 makes 6. Okay, then I FOIL. X times x squared is x cubed. X times 2x is 2x squared. X times 6 is 6x. Now I do the other term. Negative 3 times x squared is negative 3x squared. Negative 3 times 2x is negative, that should be a negative 6x. Not a positive. Double check. X squared times x squared is x cubed. X times 2x is 2x squared. X times 6 is 6x. Negative 3 times x squared is negative 3x squared. Negative 3 times 2x is negative 6x. And negative 3 times 6 is negative 18. Okay, we're good there. So this is going to change this answer down here. What's it going to change it to? I don't know. We'll have to figure that out together. So we got x cubed. We got 2x squared minus 3x squared, which is 1x squared. 6x minus 6x, well, that actually goes away. And then minus 18. There is my answer. Double check myself. I had one solution here. Since I had imaginaries, I had 2 there, which should give me a power of 3, which it does. And I'm done. So I hope this is helpful. Sorry for the few mistakes. We all learn from our mistakes. If anything, it helps you realize, hey, I can check and make sure I have the right power in the end. So today you're going to have some problems to try. Please make sure that you show me your notes next class period at the start of class.